In this lesson, we are going to have a look at minimum and maximum problems. We already saw in the previous lesson that to determine the minimum or maximum value of a function, we need to get the derivative and put it equal to 0. This calculation will then give you the x value or x values where this minimum or maximum can be found. And to then find the y value, which will be our minimum or maximum value, we need to substitute these x values back into the original function. Let's look at an example where these steps can be followed. A box with a square base is to be made to contain a volume of 108 centimeters cubed. The box must be open at the top. Let the base length be x and the height h. In all minimum and maximum problems, two formulas will be used. The one formula will have a fixed value that cannot be changed, and the second formula will be the one that will have a minimum or a maximum value. In our example, we've already received the fixed value because we were told that the volume should be 108 centimeters cubed. Question A is then, show that the total surface area of the box is given by the following formula. So our second formula will then be for total surface area. This is an open box, and I'm going to start off by determining the area of the bottom square, which will be x times x, or x squared. And to this, we then need to add the area of the four sides of this box, so 2 at the front and 2 at the back. All four these rectangles have the same surface area, so we can say that we are going to add 4 rectangles, and the length will be x and the breadth will be h. This formula now represents the total surface area of the box in terms of x as well as h. If we go and have a look at the formula that was given, it is written only in terms of x. So we will have to make a plan to rewrite the h in our formula in terms of x. For this, we will need to set up our second equation about the volume, which is our fixed value. So if I want to determine the volume of this figure, I know that it is length times breadth times height. And in this case, they told us that the volume has to be 108 centimeters cubed. Our length as well as our breadth is given as x, and our height is h. So we have 108 is equal to x squared times h. And we want to substitute the h in our total surface area formula in terms of x. So we are going to get h alone. And this will be done by dividing the left-hand side by x squared. And now I'm going to take this formula and substitute it into my left-hand formula. So in the place of h, I'm now going to have 108 over x squared. And now I have to simplify this formula. So my first term stays x squared. But in my second term, I can say 4 times 108 is 432. And x divided by x squared means I will have an x in the denominator. And here we've done what was asked in the question. Question B. Determine the dimensions of the box for which the surface area will be a minimum. So in this case, we know that the box should have a volume of 108 centimeters cubed, but the surface area should be as small as possible to make the material needed as little as possible. At the beginning of this lesson, I mentioned that to determine a maximum or minimum value, you always have to take the derivative and put it equal to 0. So here we're going to take the formula for surface area and determine the derivative. I'm reminding you that you cannot determine the derivative if there's a variable in a root or in the denominator. So here we are going to start off rewriting this formula. Our first term stays the same, and in our second term it will now be x to the power of minus 1. Now we can determine the derivative, so a prime and that will be 2x to the power of 1 minus 432 x to the power of minus 2. Then we're going to put this equal to 0 and solve x. And to solve x here, you firstly need to realize that that x to the power of minus 2 is actually in the denominator. And because of this, I'm going to first have to multiply right through with x squared. So if I multiply 2x with x squared, I'll have 2x cubed. When I multiply the second term with x squared, the minus 432 will be left. And if I multiply 0 by x squared, it stays 0. Now I can simplify by dividing by 2. So I will have x cubed is equal to 216. To get rid of the cube, I will take the cube root on both sides, and I will end with x being 6. In this example, we have a real life problem, and then it is important to remember to add your units. So in this case, x will have a value of 6 centimeters. Now we also need to determine the value for h, and earlier we said that h is 108 divided by x squared, which will be 108 divided by 6 squared, or 36, and that means that h is 3 centimeters. Question C. Determine the minimum surface area. In question B, we've already determined the dimensions for a minimum surface area. So now we can simply take those dimensions and substitute them into the formula for surface area. So there will be a minimum surface area of 108 centimeters squared. So to have a volume of 108 centimeters cubed, the smallest possible surface area has to be 108 centimeters squared.